So our team followed the engineering design process to build our product. First, we identified a problem to solve. How do we get a Alka-Sensor tablet into some water? And we decided to make a Rube Goldberg machine that would help do that. Then we went to go ahead and gather some information. To do this, each of us collectively found 3 different sources about simple machines. To find these sources, we used Boolean terms on Google, and we used our best detective knowledge to see whether or not these sources were to be trusted or not.
For the analyze and select portion of the engineering design process, we use concept screening matrices. Each person was designated 2 simple machines with 2 designs for each machine. We used it to evaluate the new concepts versus reference concepts with 4 criteria: ease of build, ease of incorporating with other machines, cost of manufacturing, and durability. These were ranked as better as a plus, same as a 0, or worse as a minus, then added up and made as a net score and ranked. The final matrix is a selection matrix, which is similar, but it has all 6 machines on one page, with 2 designs per machine. It has the same criteria with 2 additional, being accessibility to resources and aesthetic value. The criteria are weighted by importance. We decided that ease of build was very important and it should be weighted at 40%, whereas aesthetic value was not very important and only needed 5%. We then rated the machine designs. This ends up showing what machines to actually use when it was time to design, build, and test.
Summer and the sun is setting later than late.
Excellent.
Redesigning and optimizing our Rube Goldberg machine. Essentially, our redesign plan was to make sure things function consistently. We optimized our parts, and then we had to balance improvements while keeping friction low. We had major issues with the amount of friction that our original design had, mainly in the lever and in the wedge. And so by using tape, we were able to reduce the amount of friction when you use that popsicle stick right there to pop that Alka-Seltzer in at the end. Our other main improvements from our original design were the use of starting point guides. So you can see those especially on this top-down view with the funnel there. And those little spots ensured that we always had our pieces where we were going to want them between runs. So we could have our machine always functioning, but making sure that it functioned the same way each and every time was very difficult. One of our biggest improvements, I think, though, was on the pulley system. We added tape and paper guards, which essentially made it so that the pulley system could not come untangled at all. Communicating our solutions to others. So among our group, we had a pretty good idea going in what we were going to do. We had a WhatsApp group set up immediately. We had very constant communication during our redesigning and optimizing, or even our initial design. Our group worked very seamlessly together, so I don't think we had many issues communicating our solutions.
I'm coming away with the understanding that engineering is about keeping people safe in the real world.
By showing that it's just a lot of communication and group work.
This was much more hands-on, and I feel like that is a major draw to.
I'm a computer science engineer, and so all I wanted to do was code, but never actually have to build a product with my hands. But after taking this course and designing that Rube Goldberg machine, I kind of want to do something more of
finding the local environmental impacts of cardboard.
For sure, the jump from design to actual build was difficult. It just required us to push through and make changes as we went to try to make things work.
I didn't expect actually building my prototype to take nearly as long as it did take, and to be nearly as frustrating as it was.
I wish I would have known that we weren't going to build a hovercraft, but instead we were building a Rube Goldberg machine.
I think, honestly, just kind of the emphasis on how much this was going to be a hands-on class, and that most of your work was going to come from this project. You don't have experience really building anything, even just like simple designs like what we had to do were really kind of difficult to do.
It's not as hard as it seems. It's an engineering class, but it's not a difficult engineering class. And also they have a strange due date time of 5 p.m.
I wish I'd known it was going to be so much fun.